I'm here now with Dr. John Rabolt and Dr. Bruce Chase, and they're both sharing an award, the Innovation in Materials Characterization Award. Thank you, and congratulations to you both.
Thank you for having us.
What's your reaction to getting this fabulous award?
Well, it's definitely a highlight. It's always the nicest thing is recognition by one's peers. When you get other forms of recognition, they're great, but when your peers say you deserve something, it's really pretty special.
Well, because they know what they're talking about, so they really know the significance of your work.
And the impact is much broader this time. And we are spectroscopists, so we've gotten other awards, from the spectroscopy community. But that's much more narrow. But this is materials, which is a very broad field, and it's very special to get this kind of award.
The citation in the award reads, for the development of Fourier Transform Ramen Spectroscopy. So tell us a little bit about that. What are the real-world applications for that?
Well, it started literally about 30 years ago. Raman scattering is a technique which everybody knew could be powerful in the analysis of materials, but it was fundamentally limited by some physics and the problem of interfering signals. What the development of Fourier Transform Ramen Spectroscopy showed was it is possible to get good data from a wide range of materials, which opened up the application of the general technique of Raman scattering to both polymers and hard materials.
I think you could say that the development of FT Raman was driven by frustration, because we couldn't look at a lot of the materials we needed to because of those interfering signals. So we both tried various methods to get around the problems and issues we had, and FT Raman became, I was on the West Coast, he was on the East Coast, and we both realized that was the way to go.
And you're both giving presentations at this conference, so let me begin with you. What is your talk going to be about?
Well, I was lucky, I won the coin toss. I get to do the historical perspective, and the point that I'm taking is this development of Fourier Transform, or what we call FT Raman, arose from understanding what the right question to ask was. People had been asking the wrong question about applying Fourier Transform techniques to Raman, and the right question actually was, how do we get around fluorescence? And I'll show how that, again, drove this development of FT Raman. And then secondarily, I'll try to show that once we started getting spectra, the whole field exploded. In the talk, I show a plot of number of papers as a function of year, and 2.5 years after the discovery of FT Raman, the number of papers jumped, dramatically, which is about the time frame from development to other people starting to use it. So I have the historical perspective.
Interesting. So then what do you get if he gets the history?
Well, I get to talk a little bit about the application of FT Raman in the industry I was in, which was in the electronics industry. And then, since we've been working together since 1996 again, since I've been on the East Coast, we've developed a new technique called planar array infrared, which probably will revolutionize the materials world from a very fast infrared standpoint in the future. And so I get to do the little bit of the past, a lot of the present, and some of the future.
Oh, you get a pretty good deal
for
winning that coin toss.
I lost it.
Oh, you lost it, sorry. I'm getting a little confused.
Well, the interesting thing was mine is essentially easier from the historical point of view because I have all the talks that I gave. The bad news is that the talks that I gave were using 2x2 slides.
Oh,
and
no.
Try to find a 2x2 slide projector today, it's not going to happen. So some of the quality of the slides that I'll be showing, you can see they're 30 years old.
But that's okay, it's part of the history.
Yes, this is true.
Dr. John Rabolt and Dr. Bruce Chase, thank you both for joining us.
Thank you very much
for having us.